And welcome to ChatLoopBackOff, episode 68. This is the kind of project where ambassadors explore CNCF projects for the first time. And today we have Carlos here who is going to be showing Kanister. Hi, Carlos.
Hi, welcome everyone. We'll give it 1 minute before we start, and we'll tell everyone what Kanister is about. I'm also going to find out since chat loop back off from the CNCF is kind of like for people that are maybe back in the days watch the YouTube videos from Joe Beta and Duffy called TGI Cakes. Do you remember that, or you're joined the CNCF after that period? This was like 8 years ago, I think, or 7 years ago.
I have definitely joined later, but in the comments,
Oh, okay. So that's a good
please
thing.
let
I
us
can.
know.
So that's a good thing because you can go back and see some of them, but those are the old ones. You want to see those are the OGs. You want to see the ones that we are doing to from the CNCF ambassadors. So we have CNCF ambassadors. If you're scrolling and not learning what we're doing here, we're about to start to do a session, and it's similar to TGI Cakes, which basically was kind of like the SMEs of Kubernetes projects and different CNCF projects, just looking into a new project or a project that they're not familiar, and then showing people live of like how would they go about learning something new. Like maybe I know Kubernetes, but I don't know anything about Prometheus or Argo or Cert Manager, all these like plugins and additions that are in the CNCF project. So we do it together, and then people, if you are live, it's more fun because then you get to ask questions or say where you're joining from. So in the chat, I don't know if I can see the chat. Let me see. Is the chat on? We can ask people if they are here watching us live. Did you check if we're live? I don't know.
Yes, we are live. We are live on
In LinkedIn and
LinkedIn,
YouTube.
YouTube. Yes. So
Cool.
if you're watching, let us know where you're watching from. And I'm sorry, I think my camera might be stuck, but I promise I'm moving.
Yes. Yeah, tell us where you joining, maybe what time of the day you're joining, and maybe what other CNC. There's a lot of CNCF projects. To tell us which CNCF projects you want to see next from our CNCF ambassadors, to show you how to get started and maybe like answer your questions or try to answer your questions. I also invited the Kanister community group maintainers to see if they can join and also answer your questions. They're more experts on the project than me, and also help in the chat. But if not, probably if there's questions, that will be recorded in LinkedIn and YouTube, and then I'll reach out to the community members to say, hey, can you help to answer these questions that you left in the here? So if you're watching the recording, feel free to leave your comments in YouTube or LinkedIn. So with that, let's get started. Let's go and explore Kanister. If we can share my screen, we'll go over the drill. At least this is my drill where I start with the CNCF landscape. And we have more than 2,000, I think it's more than 2,000 projects in the CNCF. But maybe one day we'll cover all of them. But what we're going to do is look for Kanister, which I think is one of the CNCF projects. So one of the things that I also do is to help people navigate this UI. So one of the things that you can do is I only want to filter all the CNCF projects. Maybe I don't want to see the archive, and I know it's not graduated, so it's incubated or inboxing. I know Kanister, and I can find it somewhere here. So these are the projects that are either incubating, which is the second phase, or the first project, which is Sandbox. And you can see a few of them here. At the bottom, as you see a pop-up and about KubeCon. We'll be in KubeCon Atlanta. I'll be there. I have a few talks in ArgoCon. And the expo from November 10 to the 13th. November 9 is Maintainers Summit. And then November 8th is Cloud Native Rejects. So it's a conference that's happening in Atlanta for those in the US, and maybe people flying overseas. Do you know someone that is coming, Iris? I think she's that she put a message saying ask questions here. So yeah, that's what's happening. KubeCon November 10 to the 13 in Atlanta. So let's look for Kanister to see what is. So Kanister is a CNCF sandbox project. It has, this is the information around the repo. GitHub repo is 841 stars. This is the participation stats, funding, how many employees. This is basically like who this is not this is the last one, like how they're doing for the CLO monitor, like in terms of the licenses. These are checkboxes that they review questionnaires of, like on the project, like they're following best practices, security, legal. So legal is the license is free of, like, it's a well-maintained open source license, documentation. So they have good support. So that's the first thing. And the description, right? What is Kanister? Kanister is an extensible framework, application level. We go into that level, data management on Kubernetes. Kanister is a Cloud Native Foundation sandbox project, and it was originally created by Veeam Kasten team. So it was originally created there, and it looks like they donated it. So it says application level management. In the main aspect is backup, right? To do backup of stateful workloads that have that use storage or queues or managed queues data that they do in Kubernetes. Another thing that I like to do is when a project gets submitted to CNCF, they go to this repo called CNCF Sandbox. They open an issue like this. So they open the issue June 20, 2023. It was from the people, as you can see, the people from Veeam donated the project. So it was created in this company, but they created it. And it has all the information about the repo, and the repo got transferred to CNCF, their roadmap. All this is a template that they ask the project to do. And then basically, like these are the similar projects that are there. Many offers. So this like other projects that do similar things, and Kanister is about backup and restore of stateful workloads, like databases, for example, like Postgres. If you're running Postgres in Kubernetes in pods with PVCs, for example, you will need to back it up and restore. Something happens to that storage or to the cluster, you need to back it up. Restore databases are something that some people don't recommend to run in Kubernetes, to use a cloud provider if these things are for production. But there's also use cases that people see that Kubernetes is the tool that they need to use for that. So Kanister sits there in the same aspect of like creating. So here's a good one. So Kanister is a Kubernetes controller, operates on blueprint CRs, profile CRs, invokes action sets, and we'll look into that. Many functions in addition to scripting, action set history, and Prometheus metrics to track operations. Because blueprints and profiles are Kubernetes objects, they all foster isolation from workload configuration. So you don't have to modify your workload configuration to back it up. Reuse across different applications instances, and a single source of truth. So it's a controller with a couple of CRDs. Silando SE is another one. And then VMware Velero backups, data upload and data download. But take into account that Kanister is more like application level backup, native backup, not like taking like bytes or files, snapshots. There's services that build on top of it. So Cascade 10 by Veeam is a product. So it's used by something that is a product from a company that they use in production for enterprises. I know that because I work in AWS, and Veeam is a third party partner, and they work with customers that use CCAS. And that's basically what it takes to submit a project to Sandbox CNCF. So if you have a project that you want to submit, you can do it like this. Let me see if there's any comments on the chat as we get started. No, but if you're joining, please tune in and ask your questions here. And then what we're going to do is visit the website on the repo. So the website is this one. Let's see what is in the website. It has, this is maybe it's a landing page of like how to get started. It says git clone. Probably we'll do these commands: install Kanister, apply the bundle, but we don't have the bundle.yaml, install the application, apply the example. So there's a Mongo sidecar. So we'll see if this is just something for them to show like it's easy, or it's actually an example. I think there's a more robust tutorial in the website. So this is kind of a landing page. So that's the idea, that is to back up stateful workloads. So a typical example is Postgres, right? You're running Postgres in Kubernetes and you want to configure backup and then restore. Like if you're going to restore that database to the same cluster or to another cluster, you can do that. Use existing blueprints or authors your own. So one thing that I noticed is that they have these blueprints that basically are specific to a certain application. So, or it can be just scripting. So in this case, this is an example that looks like it's a kube exec that is going to execute something inside a pod. So it's running a CLI. So this is CLI, is like MongoDB consistent backup. So it looks like this is backing up MongoDB the way MongoDB is designed to be backed up. So this project orchestrates these kind of like recipes, but they call them blueprints, right? Of like, one is for MongoDB way of doing things, PostgreSDB doing things, and we'll see like what are the list of all the type of databases or queues, message queues, different type of data stores that they go restore. And then when you want to restore, is the restore command. So it looks like a blueprint has two main components, at least from these websites, like the backup. It'll be backed up to some place, and then it will be restore, right? If you want to restore, this is the blueprints. So this is not our part as part of the definition of running MongoDB. This is something that you deploy after you deploy MongoDB. Then you say the information of like pointing to that MongoDB to backup and restore, and then they also have migrate. So we'll look more into that. If you want to leverage canisters, it's based on the operator pattern and provides a consistent interface, meaning that they have a CRD, so they have a action set. So the blueprint is basically doesn't do anything until it gets invoked. So the action set is a action to invoke one of those things, aspects or operations that are sitting in the blueprint. So it looks like the actions is backup, and it's saying blueprint. This is the blueprint that we saw, and then what are the selector, like how do I find my MongoDB or Postgres database? You do a reference to it by GRD, like the namespace, the kind, and the name. And then if there's a profile, not sure what the profile is, but it could be like maybe configuration, if it's like production or not production. So that's it. I want to get into this to do the example. Maybe we do this one, or maybe we go to docs. We follow the docs, but maybe this is just like pseudocode to show you how is it done. So this is the, hoping that my screen is showing well. Somebody can double check. It says, oh, somebody's asking, where can I find a recording for this, as my time zone is already past midnight? Piyush, you can come back and it will be here. It will be in this LinkedIn post, same place that you put in your comment, and in YouTube, it will be in YouTube. Will not be private. So the live stream is recorded. So you go to CNCF YouTube channel, go to the live tab, and then you will see this in here. Or from LinkedIn, you go to the same place that you're commenting here. The live stream will stop, and the recording will remain. So you can go to sleep. This will be available when you wake up And ping us on Slack or DM me in LinkedIn if you have any questions. So let's get started. It has an overview and install. Usually for like landing pages, I don't want to decide. I usually want to give me one action. Like, should I do overview or should I do install? So maybe if somebody already knows what Kanister is, they just want to find a quick way to install it because they're going to install it again, or doesn't want to install it. But let's go to the overview. So design goals. I think there was a private chat. Okay, yeah. Iris is saying that the website looks okay. I don't have to make it bigger. Thank you so much. Can make it a little bit. Let me like that. So the design goals of Kanister, and this is something that I learned from Michael. He's a person, a maintainer of the project, also works at Veeam. And we did a Kubernetes book club. I invited him to one of the sessions that we were talking about backup and platform engineering. And something that it was, I don't do a lot with databases. I'm not a DBA, but he explained that it needs to be application centric. When you are backing up these certain stateful workloads, you cannot just take a snapshot, like stop the application and take a snapshot. Also, you have use cases that you don't want to stop the database, right? Users are writing to the database and you want to like take a snapshot. So if you take a copy of that PVC volume, for example, in Kubernetes, the data will be stored in a PVC, and you just grab a copy of that. It may be corrupted, it may be back up in the wrong way, maybe you have to back up certain aspects of it in a different way. So not all applications or databases are created equal and work the same way. So each one will have a particular application way of doing it. Usually they have a CLI or a script, and in the best case, they went cloud native Kubernetes and they wrote a controller that it would handle that location of that PVC, and it would handle application level operations to back it up. So given the that's basically what it says. Complexity to nature cloud, data management has to be application level. So that's what it means. An expert who possesses domain knowledge. So you may have an expert on MongoDB and another experts on Postgres, right? With years of experience on how to back this up. So it's specific applications should be able to capture these needs when performing data operations. So that's why it's kind of like unique, this project that is orchestrating the execution of those native application tools to backup. And then the second goal, it was API driven, right? You don't want to provide recipes or blueprints that is basically shell scripts. And you give people shell scripts and say, hey, run this shell script, run that shell script. If you do it the Kubernetes way, then you are doing it through the Kubernetes API. Kubernetes is around API driven development. So you, and also the declarative infrastructure, interdecorative infrastructure, or this tasks. Let's see, these tasks need to be well encapsulated into an API, providing a uniform management experience. Application experts can provide application-specific pluggable implementation satisfies the API. So you can create a framework for like different application experts to plug off, like, this is the way that the best way to back up MongoDB. So put the knowledge in a way that then it can be executed through an API. And that way, as a DevOps person or a platform engineer that you're working with Kubernetes and you're deploying these things, you can communicate better with the database folks, or the folks managing this can do it in a consistent way. And then extensible, meaning that capture needs of custom data services. So in different environments, what are the places that you're going to back up? Where are the places that you're going to back up from? Be able to extend that if you want to back up to another disk, if you want to back up to cloud object storage, right? And be extensible on like through APIs that you can like put extensions of like options. So that's it. Let's get started. It says follow instruction to installation section to get Kanister up and running and on your Kubernetes cluster. Then see Kanister in action by going through the walkthrough under the tutorial. So the architecture section provides architecture insights in how things work. We recommend that you take a look at it. Let me see the architecture. So the architecture is number 1. Let me see. Kanister is composed of 3 main components. So it looks like there's 3 main CRDs or components. Is the controller and then 2 custom resources. So it's like 2 CRDs. One action set and another one blueprints. And then there's the controller, the Kubernetes controller that reconciles as you create these CRs. It would react on events for these CRs, either an update, edit, delete. So when you create an action set, the Kanister controller would execute those tasks, and then actions executions against the stateful application that you are like pointing to. I think we saw an action set pointing to like, where's my application that I want to do? But I forgot number 2. So number 1 is action set is created. The action set will refer to a blueprint. So there's going to be a blueprint that you have to create before you create the action set that says this is the blueprint to back up and restore this application stateful. I say, okay, fine, go ahead and execute the action that is basically the knowledge of that action or the implementation is in the blueprint against the stateful workload. So I think they got an A+ on simplicity. If it's not more complicated than this, I think in the 2 minutes that I just look at this diagram, I was able to see this. Custom resources. So if you are familiar with CRDs, custom resources are kind of like the type definitions that you have in Kubernetes. There was a time that we didn't have TRDs, but that's not the case. Blueprint CR. So this is kind of like a blueprint, like I call it recipe. Blueprint is the same thing. Basically, it would encapsulate maybe the backup action, the migrate action, the restore action. As you can see here, this is like kind of like a copy paste from the Go program. So you're not familiar with Kubernetes, so you typically controllers are created. Typically they use Go, and this is like the structure of that type of definition. So it's going to be JSON. The APIs I work with JSON. It's RESTful APIs, JSON in, JSON out. And this is like the typical YAML file in Kubernetes. You always have to have a name. On the metadata, for example, a kind with its version. And then you have typically a spec, and then under the spec, you have the information. In this case, they don't have a spec, but they have top level components like config map names, secret names, input artifacts. We'll look into all those things. What is a blueprint phase? It's an individual unit of execution. So it looks like it could be the backup one, or it could be whatever unit of execution, right? It doesn't have to be, the name has to be backup or migrate. It could be an execution that you want to run. So it feels more like a script, like run this script. So in retrospect, maybe you're familiar with Argo workflows. Maybe it looks like Argo workflows. Maybe people also use Argo workflows to back up things. Let me see. Config map names, secret names, artifact are optional, but if they specify, they list the parameters that must be included in action set. So this is like requirements. Output is optional map of render parameters if they're available, and faces is a required. So you have to have faces. That's the point of like of an action set. Run one or multiple. Which phase do you want to run? The first phase is optional blueprint invoke after execution phases. So this is like something like try catch later finally. So maybe it's a finally. We specify security regardless of the status of the phases. So this is like finally, the first phase can be used to clean up the operation. So for cleaning up. So maybe residual things or notification type of things at the end. The function is required. So this is like the execution of an individual phase. Is a execution. is the function. Name is just an identifier, and map is the references to the Kubernetes object that you're going to will be performed. And then the arguments is the map of arguments that you're passing, that the controller will pass to the Kanister function. So when you run your function, it's like that. So here is a phase of a blueprint action. Let me see if it didn't say what blueprint action is, but I think it's the action set will instantiate in a blueprint action, and basically will take the information from here from actions. Oh no, this is a blueprint action that it gets created with. Oh no, yeah, I was wrong. So these are the blueprint actions definition of the blueprint, and it's a kind. So this is an instance, a CR. So in this case, these are the phases, the name of that function. It could be foobar, right? Example phase. What type of function you want to execute. So it looks like it's a keep exec. So this is telling the controller, hey, create a pod and then do an execution inside that pod. And then the pod needs a container. So it will be a Kanister sidecar container. So this Kanister sidecar, it have, at least it has hello. So you have maybe some CLI tools in there and bash. So it's running a bash script and it's doing that. Action set spec is basically, this is what the user submits when they actually want to run these actions and reference to the blueprint. So that's how I think what we saw. Blueprint is like what we discussed, and then the profile was looking before resource that will be made available to the blueprint. So it's passed as a reference. The object is like the object that is going to be passed to the action, like what are the things I'm going to run against. Pod labels, pod annotation, those are two helpful things to decorate the pods being created. So here's an example of an action. So it's an array. So this is the first action, the blueprints as we saw before, and then run that blueprint action on what. So this is where you specify, run it on against this deployment. So this object gets passed down to the action as a parameter. And then here's a profile that also gets passed to the, and this is V1 alpha 1 kind profile. I don't know what profile is, and it gets passed to the, if it needs the profile. And then the action set has a status section that gets populated with action status. And phase subcomponents, basically this is the status. Oh, here's profile. So profile has a location, credential, and if it needs to skip SSL. So profile captures information about the location of the data, operations, artifacts, and corresponding credentials that will be available to the blueprint. So I'm guessing that this is where, if I'm going to do a backup, I need to put it somewhere, and I'm going to put it in the cluster. Somebody deletes my cluster. So I'm going to put that in, for example, object storage. So maybe this is where I specify that object storage location, and the Kanister would need to authenticate to write and read to that location. So maybe this is the credentials. Skip SSL verify. I'm guessing that if you use something like Minio that implements the S3 protocol, or you have a local host that has that object location, and you're testing locally or using something like Kind, and you don't have certificates for testing purposes, you can like make it skip through. And that's true. Here's an example of the location. I was not that far. So they have constants that have like Google CS that also have S3, which is AWS and other S3 compliant stuff, and then Azure. So it looks like they have 3. I don't know if they support more than that, but at least those are the 3. The locations, for example, I'm familiar with S3. If you have S3, you have to specify the bucket name, for example, where you want to put that backup, the backup files, a prefix. Usually you can put a key, or you can say, hey, create me a key, or you can call it like a folder with this prefix inside this bucket. Region is you always have to specify the region, at least for AWS. I'm more familiar with AWS. And then the type, I'm guessing like when I'm doing S3 compliant, I'm doing this one. And then the endpoint is like more, where's that URL that you talk to S3. And for AWS is well known, depending on the region and such. Or if you're doing like something like Minio, you have to specify the local host and the port and those type of things. Credentials. So it looks like we will need to, I don't know if the tutorial will ask me to do Minio or some others aspect that I don't need an account, but we'll see about that. If I'm going to use AWS, yeah, I'll get credentials. I have an AWS account that I can use and S3 bucket and put the files there. So this is how you specify that credential information. So that's not, but that credential information is important because it's going to be part of the profile. So it could be that you're backing up in a development environment, development cluster in a certain bucket, certain region, for example, and in production you're deploying in another one, and you don't want to change the action set or the blueprint. That doesn't matter, right? This is the same. It's just it's different S3 buckets. So you would specify a different profile in that action set. Excuse me. So yeah, you will need to have a different action set. Action set points to the profile, so you have two action sets, one for profile 1 and one for profile 2. So it could be pre-prod and prod. And then the credential section will refer to a secret location, Kubernetes secret by reference. So you have to put the how you're going to authenticate. I'm guessing, at least for myself, I work a lot with EKS and AWS. We don't tend to put the secrets in Kubernetes secrets. We tend to use something like workload identity. So we'll give the controller like a workload identity that the pod is running, like some AIM identity that then that AIM can be used to access the S3 bucket, for example, in an AWS account, but never the secret. I'm guessing that they have that somewhere, so maybe we'll find out at the end. But for testing purposes, use secrets. But if you hear otherwise, though, like Carlos said, never use secrets. You always use workload identity, like URSA, pod identity, workload identity. Other cloud providers also have the same concept of like no hard-coded secrets. It's just workload identity. Trust the account or service account that is associated with the pod. Controller. So it looks like there's only one controller to run this thing. So it's not that heavy or multiple things running. Execution walkthrough. And then this is like to get the action sets that are being executed. And okay, so it's saying that when you run a describe, the events has the information, as you can see, the progress, execution, action, backup, application set, and it completed. So it concludes that the controller doesn't stop. It's basically, I think, it's running a pod that is running these things like Kanister sidecar onto ends, or it could be your controller that has the tools that you need. So I think that's good. So let's go back to the tutorial. Let's see if there's any questions that people have online. No questions. Okay. Let me hide this. Let me go back to my IDE. This. I was executing something. I was in the middle of executing something. Let me see if this thing. If not, we'll start from the demo that they have. And hopefully they have a kind cluster. So let me go back to the websites. I think we'll have side by side. So this is an IDE that has some GenAI things. And then we'll use the terminal as much as possible, unless I have to create files. Let's do the tutorial. Kubernetes 1.16 or higher. 1.16 is very old. I think maybe they wrote this when it was 1.16, but I don't know if they test with 1.16. We recommend installing Kanister 0.62. I don't know what's the latest version. kubectl install, I have that. Helm install, I have that. I have Docker. The running Kanister controller running. So I guess we need to install it. It can be installed with Helm. So I'm going to try to do this in a kind cluster. Let's see. I have a terminal here. Let's have some notes here, but let's see, we can do that like this. And let's see if I can make this a little bit PS1 shorter. There you go. And I can do kind, get clusters. I have a cluster. Let me delete this cluster. Delete cluster. So kind is a way that you can create clusters very easy and fast. So let me create a kind cluster. Create cluster. And then we'll play with Kanister in here. Does the terminal text big enough, Iris? I don't know if you can comment in the private chat. Okay, so it looks like it's watching. If I can just close this. Oh, okay, so it closed. That's good. That's good. That's good. That's good. That's good. I can move this one a little bit here. Make it bigger. So let's check if we have a cluster. Get pod/a. There's a bunch of things. Can move this one a little bit over here. Kind get nodes and pods. What was spawning here? Just typical things. DNS. So it's an empty cluster created 50 seconds ago. And then let's install the Helm chart. So the already exist. So they don't put repo updates. Usually that's good. So I don't remember when I installed Kanister. So I must have a very old version. So I need to do they should put a Helm update to make sure I have the latest one. So here, right? If not, I was going to install an old one. And then I can do a Helm install. I think I saw a comment from someone. Can I get recording of this video because here is midnight? Yes, you can. Sundar, I don't know if Siri wants to answer to the people asking. The recording will be here on LinkedIn. So you're watching on LinkedIn, come back tomorrow and same link, same place. The live stream will stop, but the recording will be available also in the CNCF YouTube channel. On the live tab, you will see this recording. And I'm very sorry that we're doing this at this time. I know in Europe is 8 p.m., 9 p.m. That's good feedback. If a lot of people from Europe, APJ, ANZ is watching, I'm willing to do one during very late night. Maybe it's morning over there, maybe very early morning. So yeah, I'm good with that. But right now, I think we're covering the US and a little bit of night EMEA. So anyway, let's go with that, and you can it's recorded, so it's you enjoy, you have the same experience. So let's upgrade and let's check if Kanister is running. It should be one container. Oh wait, so one container is running and not ready. I don't expect to be ready because well, it says here that is one. So let's do it again. Yeah, it's one. Yeah, it's healthy. Like, my bad. This ready is not like readiness probe. It's like for the Kubernetes nerd. This is liveness. Not ready, but don't get confused. Don't listen to me. If we want to see the logs, I usually like to see the logs. Oh, it says here something. Kanister is guaranteed to work on 3 most recent versions of Kubernetes. Well, they need to update the docs because they said that, use Kubernetes 1.16. So maybe I submit the PR and they'll be super happy to get a pull request from me in the docs. So yeah, and this is like they're using 3. Some other projects only support the last 2 versions. So, and they're mentioning here that it's Kubernetes 124. We work with 124, 123. I think this is very, 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 very old, or they did a typo and meant 134, 133, and 132, because the latest version of Kubernetes is 1.34. So it might be a typo. I can help them with that. To improve cluster security, by default, installation content is restricted to access only the resources with its own namespace. Oh, so this is another point. So this, I like this. Some controllers configure it to watch every namespace, any namespace. So if you create the CRs on any namespace, it will just watch it. If you make a mistake and put the things in default namespace, it may not work because a Kanister is not watching that; it's watching itself. So it needs to be everything, every CR that you create, should be in Kanister. Let me see. A resolute Kanister may not be able to snapshot or restore applications by default in other namespaces. See. Ooh, so I have a question for the maintainer. So that means my database have to be deployed in Kanister or the CR, and I can reference. I think I saw. We'll reset back if they have a namespace specified with the object. I think I saw. That the database should be anywhere. That doesn't make any sense to install Kanister 50 times because I have 50 databases in 50 namespaces. So I think it's just talking about the CR of Kanister of Kanister CRs. If the blueprint needs access to resources in another, Carlos, you have to read. If blueprints needs access to resources in another namespace, please follow the steps right here to configure access correctly. So this is RBAC configuration. And namespace creating role bindings. To allow access to create, update, delete, view resources such as deployment pods. So it's I think it's not isn't they're doing it correct. I think they're doing it correctly. It is what it was meant. The database have to be deployed in the Kanister namespace by default as a security first mindset, and that makes sense. And then making it opt-in, right? And then which namespaces are you going to be deploying a database that the controller needs access, and then you have to go the over step saying I'm going to change the RBAC for Kanister to be able to see and be able to create, update, delete things about that database in another namespace. I don't want Kanister to be watching and be able to have access to any namespace. So that clarified. This is important. This is important when people get started, right? To understand why they do things. And I cannot go back. Oh, I was there. This is the repo. So that's a good thing. Let's show what we just deploy. So these are the things that we deploy. Organize configure options. Oh, this is the value. So this is a Helm chart. So this is using the default values. This command in Helm just showed you the values. I think we're running out of time. I think I talked a lot. It's the problem with these things. Air gap installations. Yeah. Managing custom resources, CRDs, using custom certificates for validation webhook. Yeah, this is how I install Helm. So Helm basically creates a TLS certificate for the webhook. If you're installing, you can insert manager, something like that, and then building and deploying. So I think they have an A+ for documentation. So I have Kanister up and running. I can even check the logs, right? I can say get pods, get, we can make this bigger. People are gonna see. I can say get deployments /n Kanister. And I can say logs deploy. This guy is the one that I want. In the namespace Kanister. Yeah, so those are the logs. Not much to it. So it's just running there. So let's see if we can do the tutorial. Minister up. So I have that proper canister, access to S3 bucket. I can try to do that. So let's deploy a deployment time logger. So this is while true for X and then do late. So it's just doing loops, writing the date into this file, time.log, sleep one, done, and do that. So why are they saying? Because sample applications contrived but useful for most demonstration. Application appends the current time to a log file every second. The application's containers includes the AWS command line client, which we'll use later in the tutorial. Application installed in the default namespace. It would work if it's just a default namespace. It just said that Kanister doesn't have access to the default namespace. I think I'll be in a. Okay. So I'm not deploying. Now I'm confused. If the app lives in the default namespace, this thing may not work. We'll see. We'll see what's going on. Let's see the tutorial. Let's test the tutorial. Because what we just read was that it doesn't have access, so no objects passed to create. It didn't work because I'm not using Bash. Oh, something that I don't like about tutorials that include this Bash, when you copy and paste, it doesn't work. So it makes the copy button useless. Okay, we have a app. It's just running there. So let's create a canister actions. So we're going to define those actions in a blueprint. So we're going to create a blueprint that's going to back up to S3. But I need to set up like credentials, I think, for S3. So let's create that. And this will go into the canister. I need to double check if this was true. Like it can do a backup from any namespace. And I'm passing here the namespace of that deployment. So deployment.namespace. Okay, so I see. This is language that would extract information from the parameters passed in or the JSON passed in. So I don't have to hard code the deployment namespace that is in default. I don't even have to hard code the pod. It's just giving the first pod, index 0. So this is, or no, wait, this is where, no, I'm confused. Yeah, I think this is what I'm passing in. Would double check. What are these things? Or how it's going to be passed. But at least the container is, I'm going to run a container and run this. I'm not sure what this means. So they have to explain this a little bit better. So anyway, I'll create the blueprint. Melvin says, I don't know if I can type it in and show it. Speak Spanish. Saludos de venezolano en Chile. Saludos, Melvin. Sí, hablo español. Hola. Yo digo más que hola, pero anyway, let's go here. I don't have a lot of confidence that this may work, but let's see. Can prove me wrong. And again, they add this extra $sign that is not useful. I don't know where it's going to be useful ever. So that created the blueprint. So if I do get CRDs, right, I can see that I have blueprints. So I can do get blueprints in the N canister, and that's the blueprint that I just created. And I'm going to basically this is what they created. I could just copy paste this, and I just did it. So it has the information, and this message here says that the controller saw it, and I put this message in here. Like basically, this is an event. This event. View previous was created. Validation webhook. It works. Custom resources is thing, and then now it's action sets. So this action set, we're going to back up this. It doesn't tell me to do the credentials yet. Or at what point does it tell me to do the credentials? Now I'm confused. Okay. Or maybe it's just a fake thing that it does. Action set. It says, so let's go with it. It says the next deploy action set is created each time you want to execute a Kanister action. The action set contains all the runtime information to control its execution. It may contain multiple actions. It's actioned on a different Kubernetes object. The action set we're about to create is this specified time logger deployment we created earlier, and selects the backup action inside our blueprint. So our backup action is basically an echo. Okay, so it's not going to write to S3, it's just going to do an echo, but it can run whatever, right? Whatever command is just that is inside that container. And it's we're going to pass it down this deployment setting in default. This is why, so if it works, it means it was the controller can only can back up anything from any namespace, I guess. Or maybe not. And this is just, since it's not, let's test it. Let's test it because it may pass the information about the namespace and pod, but it's never going to try to access it. So maybe that's why the RBAC is fine. kubectl namespace that's running. The action set, it says it's just an action. These are the functions. Remember the functions? And then the blueprint that it was over there, this has the script about running echo, and then the object, which is an object cluster scope that you can specify on any namespace, default, time logger, and deployment. But that's passed as reference. And then that's passed as reference, and it's up to the script what it wants to do with it. So if the script command inside needs to reach out to some object or to that object, then the service account of the container, test container, is the one that actually needs Kubernetes access. We have to set up RBAC for the service account that Kanister is using to create this pod on demand. And we'll see. Now I think I understand the concept. I was a little bit lost. So let's create the action in here, and then I can show it what I mean. So that's created, and then basically, if we run this, this is the action set that we just created, right? And you can see the actions and the things that we saw, and then this is the status that is doing. So as you can see, there's an error that says time logger is forbidden. User service account Kanister. So this is the service account that that pod that is running that container that we saw that we're going to do the echo in cannot access like this. Oh no, wait. See, this is the service account of the controller, so it cannot poke on that pod. Cannot get resources deployment. Right. I'm asking for a deployment. This is the thing that I'm passing, and I'm doing a get on this API group on this namespace. I don't have access. Action in our sample pretty simple. It's probably done by the time you're finished reading. Look up the action set until the logs. Action set progressing field can be used to configure out being run currently a particular action during execution. Kanister controller emits events to the respective action set that the execution transition. So if I look for the namespace Kanister get pod controller logs. This gives me the name of the pod, not the logs, but I bet it's going to have a error message that it cannot have access. Oh, here it is. So it has some error, right? It doesn't have access because they are back. So I will not see this, right? I saw an error. So if I do the describe, there should be a error on that action set. Okay, describe action set -n Kanister. Right at the end, it says, yeah, it started execution backup, but error with the RBAC. And then, so that's why it's not working. The next one is more of like, okay, you have to configure a config map to get the location. So it's going to use this config map location to do an echo of that location. And then you can run something like backup of that location. And then this example shows you how to set up the S3 secrets. So you can have something like setting up the secret environment variables in the pod that creates on demand with access to that secret, and then running AWS S3 copy, right? Or it could be pgdump, or it could be MongoDB, or it could be whatever is the tool. And they have a bunch of tools, which I'm going to show in a minute. And then I run the action set and it runs again. So unfortunately, I didn't find how to, they didn't give me instructions on how to do the RBAC. Let me see if they have the one command to do the RBAC. No. So this is a miss in their, see, it says here, let me see if they have like a quick way for just for something, permissions, a role binding. Yeah, they don't have that. So I will need to do something like create an RBAC, like kubectl, create role, cluster role binding, something like this. Cluster role binding. Look for the service account. What's the service account name? If I can find it. Service account name with the tutorial. What's the service account? It was, oh, I have it here. Okay. So I can do kubectl Kanister admin cluster role admin role service account Kanister. Is it Kanister operator? Let me see. Kanister operator, because this is installed with Helm and didn't specify the name of the Helm. So it's all messed up. So, but it is this one. Boom. And now it has access to that. So I can delete, okay, delete dash action set, and I can create it again. And we can see it working. So let's see if we can get that far before we run out of time. What was the thing action set? Here it is, and I cannot copy this thing. So they need to work on their tutorial to make it a little bit easier. So now I can see something successful because this thing should have access now. So if I do this, see, and then if I do a describe, where's the describe? My describe of the action set. There you go. So this is what we wanted to see. So yeah, it's about RBAC, like I mentioned, by default, which is a good thing, but they should have put something in the tutorial, right? To just like, if you weren't working with kind, your own kind cluster could be permission, or give me like a one-liner to create a role to that specific deployment that I want to back up to give access. But now the controller have access and it was able to execute these things. Let me see if it created the pod or the pod is gone. So it looks like the pod is gone. I'm guessing that it creates a pod, or it might be incorrect unless they execute a container. I don't want them to create. Hopefully they create a pod or a job, kind of a job, and it will just clean up. Let me see if there's jobs in the cluster, and then I will conclude with that. No, there's no jobs. But yeah, I think that was like an overview. There's no more like time. I was able to show you what Kanister is, an overview, the CRDs, what it's used for. Let me show you one thing that I don't want to miss is if you go to their repo. Where's the repo? How do I get to the repo? I think they have a GitHub icon somewhere. Here is GitHub repo. They have a bunch of recipes. I don't know if it's where's the troubleshooting, the functions, architecture. They don't have the list here. Template parameters. They should have. It's not here in the documentation. But I know they have it. So if you go to the repo and you go to scripts, I think it's under docs, tasks, or is under, I know there's a folder with a bunch of I cannot find it now, but they have all recipes for everything. Maybe I'll put here it is. So they have like the different like tools, containers that you can use, like CouchDB, to create those things, right? This is Foundation DB, say to create that, because Kanister with kubectl. So they have like useful like containers that then you can run the tool inside. I know that they have blueprints, but I don't know where they are. Like they should be somewhere here. Maybe it's in the test. But yeah, here is a bunch of them. Candle, like they have a bunch of Postgres. Like every database out there, they have a blueprint of how to run it. It's just I cannot find it from the docs. But I think we are out of time. I was not able to. I saw it at one point. I saw it. Let me see if I can hear it's better. Build command scripts package. So they have like Postgres is here, for example. But they support a bunch of recipes. Where is it? They have a Kanister CTL CLI that you can use. Also very useful. But I thought they had a list of all the blueprints somewhere, and I cannot find it. Let me see again their documentation website. Architecture, tooling. That's the Kanister CLI. Functions and parameters. But yeah, I think I post under the comments when I find the URL for all the actions. But I think, Siri, we are out of time. We want to stop here and tell people to watch the next episode.
Yes, and all the resources that you have been exploring, they're going to be in a README file, right? In a GitHub project?
No, I didn't use any of my files. So
Okay.
everything was directly from the tutorial. So people watch, they just find I went over the tooling and installation, right?
Amazing. Well, yeah, we're a bit over time, but there's Well, we can give at least 1 more minute if somebody has some last minute questions, but if you are watching the recording afterwards, please feel free to comment. This recording is going to be on YouTube and on LinkedIn as well.
Yep.
So 1 minute, and then we're going to end it.
Okay. Yeah. I think people from Europe was watching, so they went to sleep. They'll watch it tomorrow. Okay. Not a problem.
Well, we're
See you,
5 minutes
folks.
over time.
Yeah.
Thank you so much, Carlos.
Yeah, no problem. Thank you so much.